Even in the deserts of the American Southwest, forces of nature are no match for the persistence of life. Essential elements have conspired to create life in abundance. Those elements, organic compounds and water, orchestrate all life as we know it. Do they exist elsewhere? The answer may lie just below the surface of Mars, says planetary scientist Peter Smith.
We have the potential of making a discovery so enormously exciting and basically paradigm shaking if we could find evidence that life exists on Mars.
Searching for that evidence, biologically habitable zones that may harbor microbial activity, is the focus of NASA's next mission to Mars. Led by Smith, the Phoenix Mars mission will touch down on the ice-rich northern polar region of Mars in May of 2008 to test for organic compounds and evaluate the history of the near-surface ice under the Martian soil.
NASA has a theme for exploring Mars, and we call it Follow the Water.
Exploring Mars for Smith is bittersweet. His long-standing partnership with the Red Planet was capped by success. His stereoscopic camera aboard Mars Pathfinder returning spectacular images in 1997, only to be followed by heartbreak with the disappearance of the Mars Polar Lander.
Mars Polar Lander would transmit at this time if it had entered a safe mode, and the team is standing by waiting to hear.
So we went from the wonderful success of Pathfinder with the world behind us cheering us on to becoming kind of the forgotten heroes of 1999, where we didn't return any data, our pictures never came back to Earth, and basically that ruined my career for Mars.
Not ruined were the components of the canceled missions.
And so all of these pieces were kind of floating in limbo, you know, the cameras we developed, the spacecraft that had meant to fly and weren't flying, all the pieces that we had sent to Mars and didn't work because of the crash. Well, it turns out I'm a lucky guy.
With new proposals on the table, NASA chose Smith's. He will now lead a return to Mars with NASA's first scout mission, aptly dubbed the Phoenix.
The phoenix bird symbolizes that resurrection, that spirit of taking the best of what's gone before and using it again.
Illuminating the path for Phoenix was work being done by Peter's colleagues.
I was thinking, I don't know, I'm not sure where we should go. At just that time, it was announced that ice was discovered in the polar regions on Mars.
With instruments aboard Mars Odyssey, Phoenix co-investigator William Boynton discovered a layer of ice throughout large regions of Mars' northern pole.
That was really, for me, the spark that ignited the vision for the mission.
Working in partnership with NASA's JPL, Lockheed Martin, and the Canadian Space Agency, the University of Arizona will take the science helm of the Phoenix mission. From the UA Science Operations Center in Tucson, science teams will run a series of experiments highlighted by the search for carbon-bearing compounds and an examination of the subsurface ice.
Water is central to every type of study we want to do on Mars. Landing right on top of a big sheet of ice covered with soil gave us a location where we could really explore the interaction of the ice sheet with the atmosphere, with the soil, and potentially with the biology.
After touchdown, scientists will have 3 months to complete their tasks. Weather, terrain, and other unknown challenges require expertise with an array of instruments.
Operating a mission on Mars is not a simple thing. It's a tactical process. So in order to train ourselves, we actually have the science team in our facility in Tucson operating our engineering model of the spacecraft, and then we receive the data back just as we would for Mars. The science team would have never seen what the stage set looks like, so they have to imagine what it's like in there.
The solar-powered spacecraft will return images through 5 different cameras, including one aboard the robotic arm and the U of A's panoramic stereo surface imager. JPL's robotic arm will deliver samples from the subsurface ice to the thermal evolved gas analyzer. There, the samples are heated in TIGA's tiny ovens, producing gases that can be analyzed for the mineralogy and organics of the soil. Monitoring the weather and polar atmosphere of the northern plains is assigned to the Canadian Space Agency's Meteorological Suite. Instruments will also test for a wide range of chemical properties such as salts, acidity, or alkalinity. The mission's flight will be overseen by JPL, but Smith says there are benefits to operating the science from Tucson.
There are some real advantages from operating a mission from the University of Arizona, and this is the science part of the mission. Science is really our bread and butter here at the university, and we have something that they don't have at the NASA centers, and that's students. Basically, that gives us, I think, a leg up on NASA centers or aerospace companies where they have very professional people, but they aren't training the next generations.
For the science teams, success means conquering the unknowable.
It's like throwing a dart at the map. We are exploring the subsurface for the first time in an Arctic environment. We don't know what we're going to find. On the Earth, for instance, if you go to the permafrost region of Siberia and you dig down a little ways and you take a cubic centimeter of soil and ice and you take it to your laboratory, you can find the DNA structure of the entire life tree of the Earth, from bacteria all the way up to the woolly mammoth. Is that true on Mars? Can you dig up a little bit of Mars and find that organic complexity and that kind of history of a life process? Maybe.